Hello and a very good morning to my lecturer, Madam Ong. My name is Muhammad Irfan Himam bin Aziz. My matrix number is 2213023887. So today I would like to discuss about TinyOS, which is the second assignment for operating system. Before we go deep further into this topic, I would like to share some of the contents related to the slides. The first one is the introduction of TinyOS. The second one is the goals and the aims of TinyOS. The third and fourth one is actually the advantages and the disadvantages of TinyOS. The fifth one is the example, and the last one is the conclusion. So let's get started into it. And the first one is actually the introduction. So TinyOS is actually an embedded component operating system, and the device that run TinyOS are often in low power states, remaining inactive for extended periods. This characteristic actually is a very crucial for conserving energy in battery operated devices. It also applies a component-based architecture, lacks a kernel, and does not have power protection, processors, or a memory allocation system. Interrupt and exceptional handling is directly tied to the peripherals, and explicit synchronization primitives are limited and making it as non-blocking. Also, TinyOS actually runs in NASC, which is a dialect of the C language, which is optimized for the memory limits of sensor networks. Next is the goal and aims of TinyOS. I included 3 points of it. The first one is the low power consumption. TinyOS aims to minimize energy consumption in embedded devices, especially in scenarios where this device may rely on limited power sources like batteries or energy harvesting mechanism. The way how this can be achieved is by employing a design that allows the device to spend most of their time in a low power sleep state. When active, it optimizes the usage of resources like the CPU and radio to accomplish tasks quickly and efficiently, then return to a low power state. The second one is resource efficiency. The objective is to effectively utilize resources such as memory or processing power built inside the embedded system. By utilizing a component-based architecture and minimizing the overhead typically associated with traditional operating system, TinyOS optimizes resources usage. It doesn't have a kernel, processors, or memory allocation system, reducing the footprint and resources requirement. Lastly is flexibility and adaptability. The goals of TinyOS is to provide flexibility to developers in adapting TinyOS to different hardware platforms and diverse application domains. It can be approached by allowing the design of the TinyOS to easy reconfiguration and adaptation. Its component-based architecture enables developers to create and combine components tailored to specific requirements, making it adaptable to various embedded system and application scenarios. Moving on to the next topic is the advantages of TinyOS. The first one is modularity. TinyOS is a component-based structure that breaks functionalities into small, reusable components. This makes it easier to build application by putting these pieces together. Also, each component works independently, reducing errors and making it simpler to find and fix issues. These components have boundaries, therefore they won't be interfering with one another. The second one is highly scalable and adaptable. TinyOS component-based architecture makes it highly scalable and adaptable to diverse hardware platforms and application domains. Developers can easily create customized components and integrate them into a system, allowing for flexibility in designing applications for various embedded systems. This adaptability makes TinyOS suitable for a wide range of devices with different requirements and functionalities. TinyOS also has its own disadvantages, and one of the disadvantages is steep learning curve. The absence of traditional OS features like kernel, memory protection, or common synchronization primitives, and the component-based approach may result in a challenging learning curve. As a result, it may take more time to developers to become proficient in working with TinyOS compared to a more conventional operating system. The second one is limited community and ecosystem. In comparison to several other embedded operating systems, it has a comparatively smaller community. The ecosystem may have less resources available, such as tools, documentations, and library. Next, I will be talking about the examples of TinyOS. The first one is the wireless sensor network application. In WSN application, TinyOS enables sensor nodes to collect data from the environment such as temperature, humidity, lights, and etc. This data then is being processed efficiently and transmit it wirelessly to a central node or a gateway. The next one is the healthcare monitoring devices. TinyOS can be utilized in healthcare applications for monitoring patient vital signs, managing medical equipment, or tracking health-related data. Sensor nodes embedded with TinyOS can collect information such as heart rate, body temperature, or activity levels and transmit this data to healthcare providers or the monitoring system itself. As for the diagram, this one is for WSN application. So, as I explained before, TinyOS enables sensor nodes to collect data from the environment, such as temperature, light, etc. Then, this data will be transmitted wirelessly, in this case to ad hoc routing. So, for example, if I take a temperature sensor, which produces analog signals corresponding to the surrounding temperature, can be interfaced with microcontrollers or sensor nodes running TinyOS. These sensors can be analog or digital, and TinyOS applications can integrate them with the appropriate interfaces or components. As for the health monitoring system, TinyOS can be utilized in order to monitor the patient vital signs, managing medical equipment, or tracking health-related data. Then, in this diagram, ADC is being used. ADC stands for analog to digital converter, are commonly used in embedded systems to convert analog signals such as voltage or temperature into digital data that can be processed by the system. In TinyOS-based application, developer may integrate ADC functionality through appropriate components, driver, or interfaces that allow the system to interact with ADC hardware. These components or interfaces enable the reading of analog signals from sensor, convert them into the digital values using the ADC, and then process this digital data as required for the specific application. Moving on to the next topic is how do we actually enhance the current application. So for wireless sensor network application, we can improve by develop and integrate more energy efficient communication protocols into TinyOS. These protocols will optimize radio usage and reduce overall energy consumption during data transmission. As for healthcare monitoring devices, we can develop a stronger and secure communication protocols within TinyOS to ensure the confidentiality and integrity of patient data. Furthermore, we can also integrate machine learning algorithms for real-time analysis of health data to provide early warnings or personalized recommendations for patients. With this, we can actually improve how the system works, as well as improving the credibility of the data as well as the resources intended. As for conclusion, TinyOS is a distinctive open source operating system that is specifically made for embedded systems with little resources, particularly in wireless sensor networks and related applications. The main advantages of TinyOS are its sensitivity to handling events, energy efficiency, and adaptability to devices with limited resources. Its dedicated focus on practical embedded systems applications makes it a desirable solution for scenarios where lower power consumption and optimized resources utilization are crucial, despite its potential learning curve and small ecosystem. That's all for me. Thank you.